in
Okay.
case you want to go, what did Shauna say when she was?
Got it. Okay.
Or you want to take it back to your teacher and ask your teacher what I said,
Right.
which could
Maybe
happen.
Shauna, you'll just be teaching her.
But I just kind of
Yeah.
want to give you this. There, you can find this in other places too, and your book may have it in different form.
Okay.
But I was just looking for something for us to sort of look at so we can
Okay.
kind of remember. Because polar coordinates have different characteristics
Right.
depending on if you're doing sine, if you're doing cosine, and what kind of graphs they are. So
Okay.
this is kind of our reminder about rose curves. So a rose curve is a graph that is produced from a polar equation in the form r equals a, where a is a constant, like 5 or 3 or 2 or something, sine and theta, so like 3 theta, just theta. Remember, theta counts, that's 1 theta, right? Or r is equal to a cosine n theta, where a is not 0. Now that's obvious, because if a were 0, then you'd have r is 0. And that wouldn't be a rose curve, that would be a point, because that would be a circle with a 0 radius, okay? And n is an integer. A isn't necessarily, but n is an integer that's larger than 1, okay? Now they're called rose curves because the loops that are formed resemble petals. I think we remember that from our
from trig.
blast through trig, okay? And the number of petals that we get depends on the value of n. So if you have an odd value of n versus if you have an even value of n, and the value of a, this coefficient, determines how long the petal is going to be on your curve. That's essentially like the radius. So if n is even, like if you have r is, let's say, the cosine of 2 theta, right? Then you're going to have 4 petals.
Okay.
Right? If you have 4 theta, you have 8 petals. So you're looking at the coefficient of theta. You're looking at let me annotate the screen. You're looking at this coefficient, and you're doubling it if it's even, to tell you how many petals you have.
Okay.
Okay. If n is odd, then you just have however many petals n is. Okay.
Okay.
So that's how rose curves work. Now, the thing that you had the most trouble with before, I don't know that it's the thing that you're having the most trouble with now, but the thing you had the most trouble with before was the angle.
Yeah.
And what I told you was that you always going around the entire circle, which is 360 degrees.
Right.
And that if you divide 360 by the number of petals, you don't necessarily get where they start, you get how far apart they are.
Okay.
90 degrees, okay? At where they start depends in part whether you have a sine or a cosine function.
Right.
But what I like to do is plug in the 0 angle. Then I like to plug in the cardinal angles and start there. That's not the only way to do it, but that's one way to do it. And how are you with your trig values, like your signs and with the unit circle and all that good stuff?
Well, I know how to figure out the numbers
that's fine.
pretty badly, but
you don't have it. That's fine. If you don't, I mean, if you had it a little more in your head, this part would be a little easier. But as long as you know how to figure it out, that's okay. Okay. It's going to slow you down some if you don't know some of the fundamental sines and cosines, but if you know how to figure it out, that, at this point, learn how to graph the curves, and then we can go back. Okay. So that, but that's why I'm asking that.
Yeah.
Okay. So that's how that works. Now, the next part of this, let's see what else it has on this worksheet here. Now, so these are, and I'll go over how to plot some of these when we look at it. Okay, I can look at that for you and we can see where we are. Now, the other type, you said you're not doing the limnacons, so we'll skip that one. Now here, this is we're talking about cardioids. This is going to help you with your identification of different kinds of graphs. So if you're looking at a curve and you don't know what kind of curve you have, because we have different kinds. We have cardioids, the ones that look like kidney beans with we have the limnacons that look like the Lone Ranger masks. We have the rose curves and we have limnacons. And so the easiest way to do this, not the only way, but the easiest way is to look at the ratio of your number here with the coefficient of your trig function, okay?
Okay.
And so you look at the ratio of A to B, okay? So if your ratio happens to be less than 1, you're going to have an inner and an outer loop. And so you're going to have and which side this is on, you can get more indications of by plotting it, but this will help you know if you have an inner loop or an outer loop or whatever. Now,
Okay.
this is going to give you a little bit of, I'm not going to worry about the test for symmetry and all of that. It's there, okay?
Okay.
Here they show you, this is a good example though, if you want to see how to put the numbers in and how to plot it. So if you're interested in that, it shows you how this thing is plotted. It gives you all the math, gives you all the points.
Okay.
Do that. Then you have, so here's another one. We have this curve is a rose curve. And it's got even, so it's got 4 petals. This is a 4-petal rose. So we've got this, and again, it shows you the examples, and we get our curve, and we're doing the curve, and there it is. Now they use symmetry to graph it. Okay.
Okay.
Now the lemon can have the inner loop, it can have the bump.
Okay.
So let me show you there. You can have, this is what I was looking for up here. The lemons containing sine will be above the horizontal axis. So if you have a sine, they're going to be above the horizontal axis if the plus or minus between A and B. Okay, so you're looking at the SIGN sign between A and B is plus or below the horizontal if the sign is minus. So if I have A minus B, right, then it's going to be below it. You see that?
Yeah.
Now, if the lemon contains the cosine, then the graph will be either to the right or left of the vertical axis, okay?
Okay.
And then there's differences where when you have a bump versus when you don't, which is what these ratios are saying to you. So here, if your ratio of A to B is less than 1, it has an inner loop. And here it's a plus, so it's above, and it's a sine, so it's above the axis.
Okay.
If they're equal, here, this was a sine, right? And basically you have the whole thing above the axis except for a little tiny portion below it. So you would graph the little, the origin point right here, the center, and then you would probably want to graph the point on the vertical axis.
Okay.
And then a point at 90 and 180, for example, to see, or something like that, to see where these points are. Now, if it's between 1 and 2, okay, then you're going to have more of a dimple in there, and it's going to dip a little bit below it.
Okay.
If it's greater than or equal to 2, then it's gonna be almost flat, but it's gonna hit so you can get some of this with your angles, okay? But
Okay.
this is how so you want to pay attention to, as far as the way these are, you want to pay attention to this grouping up here on the first page.
Okay.
And then you want to pay attention to the rose curves on the second page. Now you can skip the Lemnis gate if you want, but you can go to this curve and if you want to see how things are plotted, you can look at these 2 examples down here.
Okay.
But you're basically looking for these 2 at the first 2 pages.
Okay.
So that's kind of a review of what we did before. Okay.
Okay.
I'm not worried now. She may teach the symmetry, but it doesn't sound like she got into that very much.
No, it's mostly she gives us the equation and then she just starts plugging in a bunch of like
So
things and then
she's doing this down here. She's doing these.
yeah.
Okay. So all that is, as hard as that is, all that is a little bit of trig
Okay.
and quite a bit of arithmetic. That's really
Okay.
all it is. But if you're not too familiar with the measures, you're going to be hard pressed to know where she's coming up with the numbers. But I want you to know that that's what it is. It's not something that she's divining out of, you know what I mean? Which it seems like when people are doing it. Does that clarify anything?
Yeah, because I mean, I've been asking a bunch of people, I'm like, how do I graph a rose curve? And they're like, a what? I'm like, a rose curve? And they're like, I don't know what that is. I'm like, okay. I'm like, oh yeah.
So is there a rose curve in particular that you would like to graph?
I feel like one with 3 petals.
Okay. So
just trying to figure out I'm just trying to figure out where to put the petals.
Okay. All right. So we can,
I don't know.
yeah, no, I understand what you mean.
Like I know I can get one on the X coordinate and I know I can get one on the Y coordinate.
I understand what you mean. So here, okay, so let's think about this. So you want a rose curve, right? So let's look at this, because when I leave you, not that I won't be on speed dial or anything, but just so you'll be able to use this when you're going back to it, right? Rose curves, this was on our 3rd page. So if you want a rose curve with 3 petals, 3 is odd, isn't it?
Right.
So we would need something in the form R equals a sign with a, now, if it's odd and I want 3 petals, I better have a 3 right here.
Okay.
Right?
Right.
Because you told me I want a rose curve with 3 petals. Now, here's the deal. Let me do something here. I'm going to open up Desmos and show you something. Okay?
Okay.
Because this is easier to see. You can do this on your calculator as well. But I think it's easier when I'm trying to show it, it's easier to see it on Desmos because Desmos makes it larger. And
it does.
Annotate on the screen. So what I'm going to do is I'm going to switch a few things. I'm going to move. Oh, lovely. I've got my sidebar apps in the side of my Zoom and it's bugging me and I wish it would go away, but it's Zoom, so you know. Let me see if I can change this to, give me a second here. Close, okay, I close you up because I need to set the settings for something. I'm gonna set you on polar coordinates, not grid. instead of sun polar here, just to make things a little bit easier for us. Okay. Now, if I want, remember, I'm just going to do, for now, I'm just going to do R equals, now I want this to be an odd number of petals. So I'm just going to do cosine. I'm going to do 3. And I'm going to do theta. So notice if I don't have a theta there, it's just a circle. But I want my theta. So I'm going to put my theta in here. As long as I can find her. Where is she? My characters. You can tell how often I use theta, right? Let's see if I'm.
I think if you type in theta, it'll work.
Oh, I didn't think of that. But you're probably right. I think we learned that before. There we go. So now, there's my curve. Okay. Now I'm going to show you where some of these come from, but notice, why is this? This is odd. 3 is odd. And when it's odd, you get the same number of petals as that coefficient. Right. If I change this to 5, I have 5. If I change this to 7, I have 7, and so forth. Now let's go back to 3. What if I put a number in front of cosine? Right now there's a 1 there. What if I put a 2 there? Okay. What did it just do? 2. See, it makes, that's essentially the radius, right? Okay. Or the length of this petal, you see? So if I put a 4 here. Okay. You see?
And then the radius increases. Okay.
But it doesn't change the, so this first coefficient determines how far I am from the pole to a petal. From the pole, it's the length of a line through the petal. This is 7 units. Okay.
Okay.
The odd number in front of theta tells me how many petals my rose is going to have. Okay. Follow that so far?
Yes.
So far, this is what, now so we remembered a couple of things about this, right? So in terms of rose curves, let me just write this down. So we have rose curves, right? And what we've learned so far, or remembered so far, is that they come in the form, let me turn off my caps lock. They come in the form R equals a cosine theta, and I'm just going to use 0 because, I can like that. Now, if I have a rose curve, then if I have R equals a cosine, and I guess I should use n theta, right? Okay, then if we deal with cosine function, okay, there will be a petal on the horizontal axis. Okay, that's not true about sine necessarily, but there'll be a petal on the horizontal axis. Now, A determines the length of the petal, right? And n, if n is odd, okay, n helps determine the number of petals. All right. So that's what we know so far. Right.
Okay.
Now, so that's kind of what we remember here. Now, let me go back to something. Save this. Let me come back to this here. So now I'm going to say this. Here's my curve, right? So now, if I'm looking at my angles, I don't know if it's showing up well for you on your screen, but these polar coordinates are labeled.
Mhm.
They're
Yeah,
labeled. They're
clear.
labeled in terms of pi. So they're labeled in radians. Pi over 6 is 30 degrees. So they're labeled every 30 degrees here. Okay.
Okay.
I moved my curve around because my window's a little big, but here's 0, here's 30, 60, 90, and so forth, right?
Right.
Now, if you notice something, I just want you to notice this. Here's 0, so 0 is on the polar axis right here. Here's 0, right? The next petal that occurs
Is a
at 2
pi
pi,
third away.
which is
Or 2 pi, sorry. 2 pi.
which is 120. Pi over 3 is 60 degrees. Pi, because pi is 180. So pi thirds is 60 degrees.
Okay.
2 pi thirds is 120. These petals are 120 degrees apart. So there's one at 0, one at 120, one at 240, which is 120 away from here. And it's 4 pi over 3. And then one at 360, which is coterminal with 0, which makes sense. They're 3 petals. They're
Right.
120 degrees apart. Okay.
Okay.
Now, if you wanted to plot these points, okay, so it's just, if you wanted to straight out plot these points, you could do that. That wouldn't be a huge deal. Okay. I would suggest that you do this in degrees on your calculator, unless you're plotting this in radians on your paper, but it probably would be easier for you to do it in degrees.
Probably, yeah.
Initially. So when you do this, stop sharing this for a minute. So remember, right now I'm gonna bring up the calculator. Do you have a calculator in your class that you're allowed to use, a TI, or what are you using?
We're only allowed to use the basic calculator.
The scientific one?
Yeah.
Okay.
She goes and checks everyone's calculators and then is like, nope.
Well, you'll be able to do the scientific calculations that you're going to see me do. You'll be able to do those they'll look a little different, but
and then on our last test we weren't on our last quiz we weren't allowed a calculator at all.
So I'm going to put this in degrees just for so we don't have to worry about converting it. Okay. So just so you can see this. Now remember, what we're trying to graph right now is just, I'm going to graph 7 cosine 3 theta. Okay. So what I'm going to do is I'm going to put 7 and then cosine, and you'll have cosine on your calculator. Now you might have to put in the angle first and get the cosine, but let's do 0. Okay. Now I'm in degree mode. So there's 0. Okay. If I want, I'm going to change it just for the sake of showing you that I'm in degrees. Okay. Your scientific calculator, as long as you're in degrees. So 7 cosine. Now 3 theta, why did I not multiply this by 3? Well, this is 3 times 0 degrees is 0 degrees, isn't it?
Right.
So 7 cosine 0 is 7. Okay, so what that means is that you're doing this. We're doing, I'm gonna go back and share. Where's my share screen? Here, let me see. Go back to this. Can you see my Desmos on the screen?
Yeah.
So here, let me do this. Let me put a table on the screen because there's no reason why you couldn't do this. Okay, so
Okay.
if you're now, it's going to say X and Y, so you have to kind of bear with me for, but this is going to be this is going to be 0, right?
Okay.
And so you have to multiply, this is your 0 degrees, okay? So 3 times 0 is 0, right? And 7 cosine of 0 was 7, right? So that was this. Now, the next point here, if you do a certain number of degrees, now I was saying pick another number. You're multiplying it by 3, keep in mind, okay? Your fundamental angles are 30, 60, 90, and 45, multiples of those, okay?
Okay.
You're multiplying it by 3. So if you want to end up with, say, a 90-degree angle, you're going to have to put 30 in here.
Okay.
Times 30 is 90. Now, the cosine of 90, do you remember what the cosine of 90 is?
Isn't it? It's 0, isn't it?
Right. So look at 90. 90, we come back to the pole. That's why we're on the pole right here. Right.
Okay.
So
Right.
then see, this would be another one. If you put in 30 here, you're actually going to end up being at 90. This is going to end up being 0 here, right? Now, if you're at 60 degrees, okay? If you're at 60 degrees, this is going to be 3 times 60 is 180, right? And you end up with cosine of 180, that's -1. You end up with a -7. That's going to be somewhere down here. You don't have a -7 out here on this axis because they're not this far apart, okay?
Right.
So if this is like this actually ends up having to be like 40 degrees because that's your X. This is going to end up being
Okay.
at a 40-degree angle, which is somewhere, let me show you, that's somewhere here, right? So this is 30 right here. 40 is somewhere there, but you're multiplying it by 3. So you actually end up over here on this second pedal.
Right. Okay. Because 40 times 3 is 120.
So
And then
7, so we have 7 cosine. So if you have your calculator, do 7 times the cosine of 120. You
Okay.
might have to do the cosine of 120 degrees. Make sure your calculator's in degree mode when you do that, though, because otherwise bad things will happen to your answer, okay? So make sure you're in degrees for this calculation. What is the cosine of 120?
Okay. Wait, just the cosine of 120?
You could put in the whole thing if you want.
Okay.
I just don't know how different scientific calculators act differently. So sometimes you have to put the problem in almost backward.
Okay. Let's hope this works. Okay. So it's cosine 120 times 7. So that'd be 5.6.
Well, okay,
Right.
so the cosine of 120, this is 2 pi over 3. The cosine of 120 is a half.
Okay.
So you'd have a negative half.
Okay.
Okay. Make sure that, okay, let me see if I can do this for you. Hold on.
Okay.
So this is going to be, let me put it up. Share screen. So if this is 7, whoops. Helps if you choose your amount. Okay. So we have 7 cosine. And this is 120 degrees. And again, I'm going to do my angle, my degree here. Close it. And I get, should be negative 3.5. Now, if you happen to be in, I just want to check something. If you happen to be in radian mode, then let's see what you get. I'm going to go back and grab this answer, but take off my degree sign, because this is something that needs to happen to you at least once for you to understand what went wrong. Okay. You didn't do anything wrong. Your calculator was in radians.
Okay.
This is your answer if you're in radian mode. But we're doing it in degrees, so you should get a negative 3.5.
Okay. Okay.
So, like I said, just make sure that your calculator, and some of them require that you hit a button. Some of them have an arrow that you move to determine which mode you're in. So figure out how your particular calculator does that. Okay.
Okay.
But the answer that you should have gotten for this is the cent.
Got it. Okay.
Okay.
Got it.
So now, where's that coming from? Remember that this has to do with the way, it's another piece of this. This has to do with the way that we plot polar coordinates, right? Remember how we have to go backwards sometimes when we do it. So if you're at 120 right here, all right? So we're at, technically we put in 40, so we're over here somewhere, right? We're multiplying our angle, right? But we end up with a negative 3.5. So we end up with that. We go out, this is 7. So we back up along this ray, and we plot a point at that location. So when you end up with 120, which is over here, right? We end up with this point we can label different ways. And that's why we're getting that. But 120 is where we're going to have the longest, fullest petal, which is 7 units. Okay. And we're going to have another one down here. So you can plug in your numbers and find those. If that's what you want to do. But that's how you do it. Okay. Bless you. Now, if you have,
Thank you.
let me do something here. I'm going to take a picture of this. You can go through and trace your angles if you want, and there's different things that you can do to watch that happen, but let me just take a screenshot of this so that you'll have it. Now, suppose that I wanted to graph a different curve here. So suppose that I wanted to do, let's make the radius a little smaller. Let's make it 3, but then this time, let's make it 4 theta.
Okay.
3 cosine 4 theta. Okay.
Mhm.
Now, this is cosine. I know I'm going to have a pedal on the polar axis, which I do. And because this is even,
you get double the
I
pedals.
have double the number of petals. This 3 tells me what my radius is going to be.
Got it.
Okay. Now, if this happens to be a sine, let me show you what happens there. Suppose that I drop the 3 for now. If I have a sine function, let's just say I have r equals the sine of 4 theta. When you deal with a sine, again, we still have double the number of petals because it's a 4. But when you have a sine, you don't have a petal that's on an axis.
Okay.
Unless, I mean, you might if there's enough of them, but they don't start out on an axis. They start off at the slant, and they normally start where the maximum of sine would be, which is at pi halves. Okay. But again, because this is, you're dividing it by 4, this actually becomes less than that. Because this is, you see, but if I had
3.
just, let's say I had 2 theta, right? Then I get a 4 petal rose, right? And I end up with, now here, I end up with my zeros being at pi half, and then my petals are going to come out at 45-degree intervals.
Okay. I have a question, Shauna. How do you determine the different the degrees between the petals?
Okay. So there's always 360 degrees in a circle.
Right.
Okay. All of these circles are, no matter how big they are, how small they are, there's always 360 degrees, right?
Okay. Yeah.
So if you know, and this applies to whether you're doing sine or cosine, right? But this tells me I have 2 theta. So here's how this looks, because this is something that last time I don't know that you ever really got it. You kind of hung on a little bit, and I'm not sure that, but I'm hoping that now it'll sink in a little bit. So all circles have 360 degrees.
Right.
Okay. So first of all, I would say, and I know it sounds obvious, but this is how you start. You figure out how many petals your curve has. Okay. And again, that's determined by whether n is even or odd. Okay.
Right. Okay.
So if I have something like r is equal to the sine, I'm not even going to worry about a right now. I'm just going to do, this is the sine of 2 theta, right? Okay, how many, whoops. It's
a lot of
getting
numbers.
away from me. Okay, you know, it's getting away from me is what it is. Okay, 2 theta, okay? So now, how many petals does this have?
4.
This has 4 petals.
Right.
Now, this has 4 petals. Now, take 360 degrees.
And divide it by 4?
And divide it by 4. Tell me what you get when you do that.
Okay. $90.
That's 90 degrees. Now, here's the deal, okay? This means your petals are 90 degrees apart.
Okay.
Here's the trick. Here's the trick, though. When you're doing sine rose curves, you don't have a petal. Let me show you.
Okay.
You have they're 90 degrees apart, yes, which helps you, but you got to place the first one.
Right.
Okay. And what
That'd help.
happens sometimes, is students forget this. Okay, they're 90 degrees apart. So then what they do is they draw this. Here's a petal, right? They draw that. Then they draw another petal over here. We get 4 of these that look like a little butterfly, right? Thing going on up here. This is wrong because
Sine starts at pi over
sine,
4.
right? Well, sine has its max at the, remember when we do the tangent, starts at pi half, right? So your sine is going to start at a slant.
Okay.
Sine starts. So let me show you that. Let me erase this, because that's the other thing that you have to consider is, yeah, they're 90 degrees apart, but where do they start? Okay, so now let me show you this so you can see it, because it's easier to see it, I think, on the graph than it is to try and. So here's sine. Okay, now if you notice something, just look. Let me show you here. I'm going to annotate here, right? So this is where the center of my petal, somewhere here, right?
Okay.
Somewhere on this ray. And this ray, this is 30, this is 45 degrees.
Okay.
Now, why is that 45? Because this is 2 theta. 2 times 45 is 90. So my sine is going to have a max at 90 degrees, isn't it?
Right.
Because
Okay.
the sine of, that's where sine has its maximum. So that means that it's going to reach its longest 45 here, right? Now, once you place this first petal, you know this is 45, right? And you know this is 1 unit because that's 1 sine of 2 theta, right? So we know this is 45. Now, 90 degrees away from here, this is 45. This ray right here, this is, let me put it up here. This is 45 degrees. This is pi over 4. Okay, so this is pi over 4. This is 45 degrees. Okay, now if you add, remember they're 90 degrees apart, right? So take 45 and add 90. How much is it?
135.
Okay, now you're at 135. So here's 90, this right up line here, and 45 degrees later, which is over here, this is at 3 pi over 4, which is between 2 pi over 3 and 5 pi over 6, okay? This is 135, and behold, we have a petal there.
Right. Okay.
Take 135 and add 90 to that.
Okay. 225.
So down here, here's my petal. Down here, this one is 7 pi over 4.
Okay.
This is 225. And again, you can plug this into your calculator and get these numbers, but this is where, if your teacher is doing it by this method, this is how they're doing it.
Okay.
Because of the way the symmetry and the pattern works.
Okay.
And so where is the last one going to be?
90 degrees from 225.
Which is what?
Let's see. 315.
Yeah, so that's going to be at 11 pi over 4.
Okay.
I'm sorry, you know what? I made an error here. I converted wrong. This is not 7. This is 5 pi over 4 here.
And
And
then
this
that's
is
7
7
pi
pi
over.
over 4. Yeah, I made an error there. Let me fix that.
That's okay.
So this is, yeah, but it's gonna, if you go back and
That,
look at it later, it's gonna be
yeah,
like, what? She did
yeah,
what?
that,
To who?
that
Okay,
might mess me up a little bit.
this is 5 pi over 4. Now, the reason that I knew that, in all fairness, was because 11 pi over 4 is more than 2 pi. So I knew I had written something wrong when I did that. That's 5, and this is 7 pi over 4. I was thinking about 11 pi over 6 when I wrote that.
Okay.
This is 7 pi over 4. Okay, so does that help you to kind of see what's going on?
Yeah, it does.
Now, if this had been cosine,
Mm-hmm.
let me show you here. I'm going to put cosine on the same, if I can get my mouse to
So I
cooperate.
remember asking her about this, and she was like, I think they'll be the same. And I was like, okay.
If you do cosine
Yeah.
of 2 theta, okay,
Mm-hmm.
you end up with, now that's the blue one,
Mm-hmm.
you end up with same 4 petals, not 8. Okay, let me turn off the red one temporarily. You end up with the same 4 petals, right?
Mm-hmm.
But if you're doing cosine, your maximum occurs at 0. Remember, it goes to 0 and falls. So if you're doing a cosine, your first petal is going to be on the polar axis,
Got it.
which
Okay.
makes it easier to count.
Yeah,
Okay.
that'll be
What
nice.
you have to remember with sine is that you have to take the maximum and divide it by however many petals there are
Okay.
to figure out where your max is going to be.
Okay.
Does that make sense?
Yeah.
So one more thing here. If I
Yeah.
were to give you something like, let me turn these off. If I were to give you something like R, and I'm going to use a sign because we haven't
Okay.
used too many of those. Let's say I gave you the sign of um, the sign of 4 theta.
Okay.
Now you're looking at it for a reason. I want you to be able to look at it
Okay.
and see this while you're trying to do it.
Okay.
First of all, you know it's a sign.
Okay.
So
Yeah,
you
because it
know
doesn't
that
start at the.
you don't
Okay.
have a pedal on the polar axis, which is the horizontal.
Right.
You don't have a pedal there. Okay.
Okay.
You got to figure out how many petals your rose curve has. This has
Mm-hmm.
8 because this coefficient
Is even.
is even. Doesn't matter if it's sine or cosine.
Mm-hmm.
It's even, so you have 8. So I know that this one has 8 petals. Now, the hard part of this, got to figure out 2 things. If you think the way Hannah thinks, and it's a good way to think, you got to figure out 2 things more. You got to figure out how far apart are my petals,
Right.
and where do they start?
Right.
Because you told me if you're sine, you don't start
At the
on
polar axis.
the axis. Why? Because 0 sine doesn't have a maximum at
Right.
0, does it? It has a
No.
maximum at pi halves.
Right. Okay.
Okay. So you have 8 petals. Let's do the easier part first. How far
Okay.
apart are they going to be?
Okay.
All circles are 360 degrees around.
Okay.
Divide that by 8 for me.
Okay.
Tell me what you get.
Sorry. don't know
Take your
why.
time.
Goodness, I can't even think. Goodness.
360 divided by 8.
Sorry, I got a concussion. So I'm a little it's a little fuzzy up here. 34,
Do you really?
I did get one, yeah.
Oh my goodness. Wow.
45. There we go. Sorry.
40. No, no.
Yeah, I
I
got one playing water polo 2 weeks ago.
that's good to know. So if I see anything, I'll be
No,
aware
don't
of it.
worry. I am pretty much back to normal. It's
Yeah, it
just
seems like you are, but
things
it's
are a
good,
little fuzzy up there.
good to know. If 45. So this means that your petals are 45 degrees apart. Okay. This doesn't
Okay.
tell you where they start, though, does it? So remember, so where I'm going to put recall, because I'm big on that word recall, right? Recall or remember, recall that sign has a max at 90 degrees, right? So what we're going to do is we got to figure out where the first petal is going to start. It's going to normally would start at 90, right? But we have 8 of them. Yeah. So what we're going to do here is we're going to divide this by 8. Now, if you look carefully, it's probably hard to see this. Let me try and zoom. Can I do this? Will it let me? Probably would if I moved my mouse. If I move this over, kind of squeeze this down a bit, and we can kind of see this better. So this, let me pick up my spotlight here. This is our 90-degree line, right? Notice we have 2 petals in there, right? And so these are 8 petals and they're 45 degrees apart, okay? So our first petal, your first petal is going to be, let me write the calculation so you can see it. The first petal would have to be on 90 divided by 8, which is 10 degrees. It would start at, so your first petal, now this is a little bit hard to see because you have to think about, let me draw this. It's not where it's where this line goes through the petal. You see that?
Yeah.
So this line goes through the petal right about here. Halfway through the petal, somewhere here. Right? This line here is 30 degrees. Okay. Now from this 10, where's the center? Now the next petal, let's put this here. The next petal has a line that's a little more believable. Right about here. Now this petal here, this is 30, right? So now if this is your this is going to be your petal. This angle here is going to be the angle between this here. Okay, cursor flew away from me. Wait. Oh, Cursorville, there it is. All right, so this angle here is going to be about
45 degrees.
45 degrees, okay? It looks a little exaggerated on the screen.
No, it looks perfect.
But it's this angle should be 45 degrees. So wherever this started, this angle is going to be, now, this is pi over 6, okay? Pi over 3, rather. So you've got this angle here, okay?
Mm-hmm.
So now I've got, these are 45 degrees apart. So now this angle, 10 plus 45, which is 55 degrees. Now this angle should be at, I have it, this line's a little bit over where it should be. So let me erase this so you can
Hey, Shauna,
actually,
I just really quick want to make sure. What time did you have to leave again?
I have to see if I'm gonna text my student and see. He says he's not able to make it
Oh,
today.
okay.
That's
Okay.
why I wasn't rushing you. Um, I wasn't rushing you because he does this quite a lot.
Okay.
He's
I
pretty
was
good at
just
telling
making
me, but
sure.
I was like, let me not schedule in case he's not coming because he has a lot to catch up on. So,
Okay, because I was gonna say I'm just making sure that like
no,
you're good.
I appreciate it, but today you're safe. Wednesday, if you had asked me on Wednesday, Wednesday's bad because we have a new housemate coming in.
Okay,
And we
I
have a
see.
house meeting, so I'm gonna be in between meetings, popping in and out, doing all that.
Yeah,
So Wednesday is kind of, tomorrow I would probably have some time, but like I said, that 4:30
yeah,
slot is just not a
yeah.
good one.
I get done with practice at 4 and I'm just trying to figure
So
out what.
we might have to push it. We could push it a little bit later, but I
Yeah.
mean that was how that went. Now the reason I wanted to kind of erase this, not because it's wrong, but because it's not to scale, and it's going to mess you up if you are looking at this, because your next pedal should be at 55. Okay,
Okay.
which this looks like, this makes it look like it's at 63 because of the size of the line I drew. But
Right.
that's where this is coming from. But that's how you figure out where, that's how you figure out where these things are.
Okay.
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 So let me undo, and undo that. And you can see that here's my pedal, right? And
Mm-hmm.
then there's another, these pedals here, these two, not the one. So the one here, let me spotlight it. The one here is 10 degrees off the axis. It's not 30 because 30 is this line.
Mm-hmm.
And
Right.
this is considerably less. This is, you see, this is
Yeah.
where your pointer is, right? And then
Mm-hmm.
the next one is here, which is at 55, you see?
Mm-hmm.
And then you have another one 45 degrees after that,
Okay.
and 45 degrees after that, all the way around to where this ends up, you see?
Mm-hmm.
That's how we got to that point.
Okay.
Okay, so does that kind of help you?
Yeah.
Now,
Yeah, that makes sense.
if you're doing Limacons, okay,
Mm-hmm.
it really, because Limacons have 3 different versions, or 4, depending on how you think about it. Limacons have several different versions. So what I'm going to do is I'm going to get a new graph here, okay? And I'm going to make sure, I'm going to clear my drawings out, and I'm going to make sure that we're in polar coordinates. And are you looking to graph anything in particular, or was it just
Um,
the idea of
just the idea kind of like
graphing?
threw me for a loop 'cause I wasn't there
Okay.
for that lesson.
But is this helping
Yeah.
any?
Oh
Okay.
yeah. No, totally.
So if
'Cause
this is a lemison, right? Let's see if we can go back to something here. Go back to our cheat sheets. Hold on.
yeah, 'cause that
Runs.
that definitely helps because I'm trying to figure out where.
The cheat sheets help a lot. So let me go back and do Let me actually send you the link while I'm here. Where is that? Hello. Oh, it's in here. That's why. Because I put it in here. That's where it is. Let me drop this link in the chat for you so you can
Okay, cool.
look at the same thing I'm looking at. So
Bookmark
this,
it.
so you can tell her that they're not the same in
I know,
general.
because I was trying to figure out, because I
And
was
you
like,
can
I know
tell her,
something. I was like, I know something's different. And I was like,
and you can
and then I
tell her,
asked her, I was like, how can we tell the difference between sine and cosine? And she was like, no, I think they're pretty much the same. And I was like, I don't remember them being that way.
cosine starts, if you're talking about rose curves, cosine starts on the polar axis, sine doesn't. And it
Right,
has to do with the fact that where sine has a maximum.
right. And sine starts again at 90.
The sine has a maximum at 90 degrees.
Okay,
It doesn't necessarily mean that it's going to start there, but that's where
okay.
I'll show you. There was another, I'll see if I can find the video that we did, but let me put this in the chat and we'll handle, but you can tell her that you learned
Crack that
that.
case.
You have a
Yeah.
question?
No, I was just like, I cracked that one. Figured that one out.
Oh, I got you.
Yeah, no, figured that one out now.
I think it
Yeah.
actually pasted. I'm not sure why it did that, but let me see if I can unpaste this. Because it pasted a picture of the screen and I didn't want it to paste a picture of the screen. I wanted it to paste a.
Technology, I tell you, it's
I didn't know you could do that. I
oh,
honestly,
screenshotting.
I didn't know you could paste whole. I learned something, but I didn't know you could paste a whole screenshot into the.
Yeah, if you do Control Alt and then the Windows key, and then you do Control V, it'll paste for you. I think that's how that works. I think I've done that before
Yeah, but I
too.
didn't realize you could paste a whole screenshot into the chat
Oh
window.
wait,
And
into the Zoom chat?
I did it without, I think so.
That's pretty
I
cool.
think
That's
I
actually cool.
managed to do a thing without knowing how it's like, don't ask me how I did it, because I don't think I could do it over again.
I didn't know you could send images in the Zoom chat.
If you paid me, but I think I managed to. I think I managed to do that. Let me see if I.
Happy accidents, right? Happy accidents.
Well, yeah, but I wasn't really, thing was, I wasn't really looking to do that. So I don't know that it actually works. Okay, this is what I was gonna send you. There we go.
There
All
we
right,
go.
so there's
Oh
your.
yeah, you did send a photo. That is pretty cool.
I didn't realize I could do that.
I didn't either. That's pretty
I
cool.
think what I did is hovered over it and hit Control V and it pasted the screenshot of the window, which good to know,
Yeah.
but like I said, I'm not sure I could do that twice to save my life.
That I
Anyway,
mean, that's a pretty cool talent. It's pretty cool talent. Pretty cool
that's
trick.
how that works. Okay.
Okay.
So
Okay.
now, now we're down to the snails. Remember, this is the fancy word for snail in French that they translated, right?
Right.
And so Limacon, right here, this is the next page. If you look at the Limacon, they have two rules. R equals A plus or minus B sine theta, where A and B are both greater than 0, or R is equal to A plus or minus B cosine theta, right? And we have 4 different versions, depending on how curvy the middle gets. And that depends on the ratio of A to B.
Right.
Which you can follow here if you want.
Okay.
I'm not going to go into a huge amount of detail, but I will say that if you have a plus sign and it's the sine, okay, then you'll be generally above the horizontal axis.
Okay.
If you have a minus and you have a sign, you'll be below the horizontal axis.
Okay.
Okay. And this makes some sense because remember, sine has a maximum at 90. So if you're adding, you would expect this to be above the axis because you'd be plotting the points above the pole, above the origin.
Right.
Now, if you have cosine, which they didn't show on this picture, but if they had cosine, if this was a plus and a cosine, you'd be going to the right. If it were a minus and a cosine, you'd be going to the left.
Got it.
Again, how much curvy in you go, whatever, right? But that's essentially how it works. Now, in terms of actually doing, this is one of those cases where this might actually be instructive to go through some of the math for you, just so you can see how some of the math works. So here, if you look at the third, it says, graph the polar equation r equals 1 minus 2 cosine theta. Okay, this is a snail curve with a equal to 1, b equal to 2, and a minus in the middle. Okay, because it's a cosine, you're going to open either left or right because it's cosine. Because it's a minus, you're going to open to the left, and we do.
Okay.
All right. So snail curves, if it's a minus and a cosine, you open in the minus x direction. The way I kind of remember this when I haven't taught it for a while, the way I like to remember it is this. I like to say that, here I'm going to do, where's my annotation tools? Here it is. Okay, so I'm looking at this here, and I'm going to say my cosine is associated with x.
Okay.
Right? So it's going to be on my horizontal axis. Can't really call this the x-axis on a polar curve, but you can get away with it as long as you're not too. Oh, okay, so cosine is associated with your x. If there's a minus between these, then so a minus b means the curve opens in the negative, the minus. This is my little mnemonic. It's not totally the way that your book is gonna tell you. I mean, it's not wrong, but it's just a little bit less formal than your book will.
Okay.
The negative or the minus x direction, which is what this says. Okay. If there's a plus there, then it's gonna open to the right. Okay. Now, how curvy this gets, like how much loop it has and whether it loops over or whatever, that has to do with the ratios of A to B that I was showing you before. Those, so you really have 4 directions, but I just look and say, well, if it's cosine, it's going to be some X direction. And then I just have to look at the middle. If it's a sine, it's going to be some Y direction. And again, I look at the middle. Is it positive or negative? And that's what So that's how I do it. Now, in terms of doing the math, because this is what you said she did, I think this is one of those cases where it's probably instructive to look at how you actually go about doing it.
Okay.
Do it. So here I'm going to going to clear the drawing. And I'm going to show you on the next page. Let's scroll down. So here she gives you the angles. So she's putting in some angles. Okay. She does the symmetry test. Don't worry a whole lot about this. Okay.
Okay.
This is useful, but it's probably beyond where you are. Focus on
Okay.
this. So here she's looking. Now notice, evaluate R at different values of theta. Okay, we know how to do that. Why is she using these values? These are fundamental values of the angle.
Right.
Pi over 6, pi over 30, 60, 30, 45, 60, 90. So
Okay.
she's evaluating the 5 fundamental angles. All she does, plug them in there. She plugs it in. So 1 minus 2 cosine theta is 0. Okay, cosine of 0 is, now here she did all the arithmetic for you. That's why I wanted you to see this. Okay, you can do this with a calculator, but I wanted you to see this because she actually does the arithmetic. So you can see where these are coming from. Cosine of 0 is 1. So 2 times 1, 1 minus 2, negative 1, 0.0 and negative 1.
Okay.
Pi over 6, that's 30 degrees. 30 degrees. 1 minus 2 cosine pi over 6. This is radical 3 over 2.
Okay.
So she simplifies. Here you get a decimal. Plot the decimal, 0.8, whatever.
Okay.
Whatever you want. This is how they do it.
Okay.
They put it in there. They plot. Okay.
Got it.
She does some more angles. She does the first 2 quadrants.
Okay.
And then what she's going to do is use symmetry to plot the rest of it. But you could conceivably continue around if you wanted to. But I think symmetry is less, for you right now, that's less important.
Okay.
But I wanted you to have an example of doing some of this math. But that's really all you're doing.
Okay.
It's plugging in those fundamental values around the unit circle. Okay.
Okay. That doesn't seem too scary.
This is a rose curve.
Right.
Okay. This is a rose curve here. The polar equation is in the rose curve and is even. The 4 will have 4 petals. We know that. We're not going to worry about the symmetry, right? So here, notice you have a point, then you have a petal. And so because this is a cosine, we start at the pole, and every 90 degrees, we have a petal, and lo and behold, there it is. There's a petal there. And then if you go to pi, we'll have another petal. The points will provide us with enough points to complete the rest of the craft, and you can begin to see it. You know that you have, when you plot these points, you know how many petals you should have.
Right.
So you know how to complete the rose curve, and there are 4 of them.
Right. Okay.
Because there's 1 above, 1 below, 1 over here, and 1 here. Okay. So symmetry will help you to complete some of that. Okay.
Okay. Okay. And then real quick, could we do this equation?
Sure.
That's been bugging me. It's okay. It's r squared equals sine theta. And then she wanted
r squared is sine theta. Okay.
Yeah, r squared equals sine theta.
Looking for the rectangular coordinate?
Yeah. Oh my gosh, it's been bothering me because on our quiz, she never went over it. And I was like,
she didn't go over it when she turned it back. Maybe she didn't know. R squared. R squared.
I knew how to get, knew r squared equals x squared plus y squared.
Okay.
But I knew that I thought at least that I needed an r for sine to make it into
Well, it would help.
y, right?
That would help you, yeah.
And so I didn't. So then I multiplied it by r, and then I didn't know what to do with r cubed.
Now
and
you
I
have
was
r cubed, okay.
right, and I was like, what do I do with
R
r
squared is
cubed?
equal to the sine of theta, right?
Yes.
Well,
and then
so
I didn't know if it was a typo because she tends to have those.
possibly, but if you that's if she tends to have those and she didn't go over it, then I would maybe tend to think that it might have been, but it still can be done. It's just
Okay.
it's just not going to be as nice a curve as it would have been otherwise.
Yeah, because she tends to have a lot of typos, and we end up tending to cross out a lot of questions during our test.
Because it's not correct.
Right. Or there's
Yeah.
duplicate questions, or not what she wants us to find, or
Yeah, no, I get you. I'm looking to see if there's, yeah, they have 2 sine theta. They have a bunch of these, but they don't have r squared is equal to the sine of theta in rectangular. Because this is going to be they have r equals 2 sine theta, which is probably what you thought you were doing. But in this case,
wait, no, it was r squared equals 2 sine theta.
2 sine theta?
Yeah, I think so, yeah.
R squared is 2 sine theta. So here,
and
so this one, 2 sine theta.
Yeah, it was 2 sine theta. It was r squared equals 2 sine theta.
2 sine theta.
Yeah. And I didn't know what to do with it.
2 sine theta. Well, it's just gonna, I would probably have made it r cubed, as you said.
Okay.
R cubed.
Well, at least I got one thing right.
Unless this had an r in it already.
Right.
Right. So, but I'm assuming that it didn't. So if you don't, you put an r over here. So this is 2r sine theta, right? Now, at this point, you remember you still do have a rectangular form for r. It just has a square root in it.
Okay.
Okay, that's all. But this so this 2r, then r sine theta, do you remember what r sine theta is?
It's y.
Right, so this is 2y on this side, right?
And this is what I did. And then I freaked out about the
That's
r
2y.
cubed.
Now this r cubed, remember this is r squared times r, which seems obvious.
Right.
But remember, you know what r squared is.
Right, it's x squared plus y squared.
So this, you're telling me, is x squared plus y squared. Now, I told you it's not going to be nice because I don't think this equation is what she meant to give you. I think there was probably either one less r over here and an r here, but it can be done. So this is x squared plus y squared, right? Now this r, what is r? Just r by itself.
X plus y?
No.
R by itself. That's
so remember, r squared is x squared plus y squared.
Right.
So r is just the square root of this.
Right.
Right? Because isn't r just r is the square root?
Right.
Of this, right? X squared plus y squared, yeah?
Right.
Because that's the definition. Only we always square the term, don't we? But it is this, isn't it?
Yeah,
so if this is x squared plus y squared, and I multiply this, now Depends on how much algebra you want to use. Okay.
Okay.
This R that's hanging out that you put in there to make this
Mhm.
be a Y now, this is going to be square root of x squared plus y squared,
Okay.
right? That's why I said I don't think it's what she meant to give you,
I don't think so either, but
but I mean, I'm assuming that she meant for this to be R. If there was an R here, she just probably meant for this to be R.
right.
And then you would get x squared plus y squared is 2y, which would be a circle, right?
Right.
But x squared plus y squared under the radical. Now, if you wanted to be a little more algebraic about this, right? This is 2y, right? So this would be 2y still. And if I wanted to clean this up a bit, this part here, I've got x squared plus y squared in two places. This is really like x squared plus y squared to the first. And this is x squared plus y squared to the half, right? So I could write this as, if I wanted.
She definitely meant to give us this problem because we went over our homework one time because this is her thing where if we go over one thing one time, we should know how to do it. And I think she did go over this one time with our homework because I remember her switching it to
X
like
squared plus y squared. Now, this is, I'm just going to use the power. So this is the first power, right? This thing in parentheses, this is a half because it's square root, isn't it? So then 1 plus a half, this would be 3 halves. So you get x squared plus y squared, which would be a really odd equation to graph. X squared plus y squared to the 3 halves is equal to 2y.
Okay.
And I assume that she would not want you to solve for y because that would be really ugly. So I'm assuming that an implicit form, but you could do it, but it's not something that we're entirely used to.
Well, Shauna, you haven't met my math teacher.
Well, yeah, if she thought that the r cosine theta and r sine theta are the same, I worry.
Me too.
But is that helpful?
Yeah, and then can we do one more? I don't know if I remember it fully, but I remember it being like theta equals 0.
Okay.
And then I don't know what to do with that.
That's actually not as, it's so sort of so fundamental that it's not something we're used to. So if you have theta,
because I saw it and I was like, theta, I think I could turn that into
if you have theta,
yeah,
that's just your angle, right? Now, if you have theta equals some constant, this is theta equals 0 degrees, right?
Right.
Now think back, you have to think about your definitions, right?
Okay.
How do you get, now normally we think of tangent inverse, right? Theta is tangent inverse of y or x, something like that, right? You remember?
Okay.
So remember let me show you something. Let me help you a bit with this, because no, this is not hard, but it's
weird.
It's not something that we necessarily think about all that much in terms of I just want you to see, let me see if I have it. Yeah. Where, because there's a few of these online. I just want to see if there's a few of these. I want to see my formulas. So now this is giving me a circle. Okay, this is giving me a polar form. I don't want to do all that. I want to see, hold on. these are giving me, okay, so rectangular to polar, and I want theta
Yeah,
equal.
she just,
Huh.
I don't even remember going over questions like that in like class. Like I have no recollection.
You probably did, but you might have done this more, and she might have assumed that you did this in pre-calc.
You mean trig?
Well, yeah, trig. You did a lot of these in trig
Yeah. So I was
issues,
gonna say I'm in pre-calc.
but yeah, but weren't you
Yeah.
doing like a combination? Weren't you doing some of this in algebra too? Like,
Not really. No.
because
Algebra
I
2 is
remember you were doing some weird
trig. I remember a lot, like trig, we had a lot of like, I feel like pre-calc's just the review of trig. Like
it's a lot
it's a
of trig. There's a lot of trig, but there's also a lot of algebra
um
in it too, depending on, I'm surprised you haven't started doing like polynomials and
no, yeah,
whatnot.
that's the stuff I like. I'm like, I mean,
Like the factoring and all that.
I'm praying for
You're waiting for that to arrive.
I'm praying for that.
It's coming. It just hasn't arrived yet. I'm looking to see if I can find you
No,
a.
I think we've done a little bit. We've done a little bit of it, but not as much as like we did in algebra or anything like that.
I'm trying to see if I can show you, but it doesn't really have a good example of this.
Okay.
So I'm trying to see. It's showing me a lot of polar equations right now, and I'm not really looking at that. There was one video on it that I sent you but I'll show you if I'm just looking to see if they have an animation, because it would be cool if they do. But who knows if I can find that. Are you off today? Are you doing
Yeah, I
a
am.
President's Day holiday
Yeah. Yeah. It's
shuffle
been
kind
very
of thing?
nice.
I can imagine. I can imagine. Theta
It has been very nice. Yep.
equals 0.
And my teachers have all given us a lovely amount of homework.
Yeah, I can imagine, because they want to keep you busy, right?
Yeah. Oh yeah. My AP Lang class, I love it. It's great. But
Oh, nice.
we have a op-ed analysis paragraph due,
Okay.
which
All right.
it's not hard. But it's time consuming. And then
Yeah.
if I pass the AP test for it, I can skip English 101.
Cool. Very good.
So yeah, it's really
Yeah.
and we're doing a mock trial coming up, and
Oh,
it's aliens versus the humans. And I forget
are you going to talk
which
about Chat GPT and the whole?
it's basically, I don't know if you've ever, I don't know where show or whatever. It's from an older show, and I guess they get tricked by aliens, and these aliens come to Earth, and they're like, "We want to serve you," but they don't actually want to serve them. They actually want to eat them,
Oh, wow.
and so they lie to them, and they're like, basically,
Crazy.
they're like, "We're your friends. We want to help you. We want to get world peace. We want to do this." And they're like, "Come to our planet," and then they actually take humans and start eating them.
Oh,
And so
nice.
yeah, and so I think that the mock trial is basically going to be about were the aliens in the wrong so and so. So
Oh, okay.
I get to argue for the human side, and I have no clue where I'm going to start with that. Because I feel like,
Do you have to talk about like their values or?
yeah, basically, it's basically talking about like, well, the aliens tricked the humans, right? So therefore they should be punished. But then you can argue like, well, technically what the aliens did to the humans is what humans do to animals on Earth, if you think about it, like fully.
Mhm.
and then you have to figure out how to like get the jury to be on your side, and you have a jury of your peers and stuff. So
why shouldn't they kill you? Is that kind of
right,
how?
pretty much. Yeah, why shouldn't they be allowed to eat humans?
Oh, wow. Interesting.
Yeah, but I'm excited. I think it's gonna be fun. So we'll see. But
Okay,
it's just
let me, I'm not finding
no,
what I
you're
want, so
good.
let me wing it a bit. All right.
Okay.
Not that, I mean, I can give you an answer. I just don't quite know where. So when we do this, one of the
Okay.
things that we know that we start, or maybe you might not remember because there's been a lot going by in the last, I don't know how many weeks,
Yeah.
but
Yeah.
we start with something like tangent theta.
Okay. That's what I did while I was winging it.
Remember,
So
tangent theta, it's y over x, if you remember that,
yeah.
right? Tangent theta is y over x, right?
Uh-huh.
So if you had, now, that means that what they've given you, you're looking at theta, right? So if I wanted to solve for theta here would be, if I plug this in and I want to solve and get this in rectangular somehow, theta is the tangent inverse of y over x.
Okay.
So remember, theta is an angle, and it's the inverse tangent. So the tangent of some angle that I don't have is equal to 0. Tangent inverse of y over x, right? Or arctan. If you're used to writing arctan, you can write arctan here. Tangent inverse y over x. So now this is tangent inverse y over x. So here, now theta is the tangent inverse of y over x. Well, this is, 1 is convenient here. So let's, right? So theta, so I can say that theta is the tangent inverse of 0. Would you agree?
Okay. Yes.
So theta is the tangent inverse of 0. Now, so I can say, so what I'm really looking at is the tangent inverse of 0. So that begs the question, what is the tangent inverse of 0? Well, that's 0, okay? Tangent of 0 is 0. So here you have theta is the tangent inverse of 0. So if you were to look at theta 0, this is the tangent inverse of 0. This is a quantity of this number, right?
Okay.
So this is a point. Theta, because if you think about, and this would be easier to see, this is one of those cases where this is not really a graph, and I'll show you. I mean, it is a graph, but not really. Let me show you what I mean. If I set this up in polar and I write this, if I say theta equals, let's try 1 first. I'm going to do 1 here. Theta is equal to 1. Now this, okay, this is not a function of anything yet. Of course not. See, because it's telling me that I don't have, if it won't graph a line. This theta is equal to 1 is just, Desmos won't. Now I can make it do it if I graph a line, but I would have to, it would be good to know that Desmos doesn't know how to do that. This, if theta is equal to 1, then I'm looking at, here's pi over 4, remember?
Right.
So here's the pole, right? And I'd be looking at theta equal to some number would just be this. If I can figure out, okay, draw, select, no. I don't want to see you. I'm going to do that. Okay, now let's see if I can draw. Can I? Are you going to let me draw on you? No, you're not. All right, let me move you out of the way. And you know what I'm going to do? I'm going to stop sharing because for some reason, okay, so here, let me annotate the screen. Okay, so I think we're good now. We'll see. Yeah, this looks better. This is promising. All right, so if I'm looking at this is just this 45-degree line. Theta equal to pi over 4, it's just this line through pi over 4, and it would go both ways depending on how far it went, right? Now, if theta is equal to 0, here's the thing. If theta is equal to 0 degrees, then what I'm essentially doing is I'm graphing. If I take this out, here's, remember, 0 degrees is my positive horizontal axis.
Okay.
Right? So, because remember that this is 0 here, right? Theta being 0 degrees means that I'm essentially graphing this axis. I'm essentially graphing theta 0 degrees. I'm looking at 0 degrees and I'm graphing the x-axis. Okay. But now tangent of theta is 0, right?
Mm-hmm.
So that tangent y over x is 0. So if I'm looking to transform it, I'm just going to get the tangent of y over x because theta is the tangent inverse. You know what I mean? All I'm going to, if I want it in terms of y and x, then I'm going to have to use tangent to do it.
Okay.
You follow me? But if you know that it's 0 degrees here, then you're really looking at the line y equals 0.
Okay.
Okay. Because again, tangent is y over x. So if you write theta is equal to 0, and you know that the y over x, right? You write tangent theta is y over x, right? Then you can say that theta is the arctan, or the tan inverse of y over x, right? Which is what I was doing on the whiteboard earlier, remember?
Right.
This is where you end up. Now, if this is 0, then you have 0. 0 is equal to the arctan of y over x. Okay. 0 is equal to the arctan of that, right?
Okay.
Now, if I wanted to solve this, I would take the tangent of both sides, right? So then I get tangent of 0 is equal to y over x. Well, what is the tangent of 0?
would be
That's
0.
It's 0.
Oh.
Right? Tangent of 0 is 0. So I get 0 is equal to y over x.
Okay.
And assuming that I'm defined, right?
Right.
Then that means that y would have to be 0.
Okay.
So I'm looking at the positive portion of the
Right.
x-axis.
Oh, so that
Normally this is a number like 1 or
Right.
like 1/2. This will be an angle of some kind.
Okay.
So this will be one of these rays
Right.
out at an angle.
Which normally it'd be like theta 45, like right? 45
Theta.
degrees.
So if you had theta equals 1/2, right?
Right.
Then you'd solve for whatever that theta was. But that's how you get to this line. You see?
See, I thought this was such a weird one. I literally had no clue what I was doing. So I basically did what you did, except the only thing I didn't do was multiply by x. I literally left it as y over x equals 0 because I had no clue.
That's not necessarily a bad thing.
Yeah.
But the only reason I did that here, I made an assumption that this is defined.
Right.
Because x, you're not going to have a situation where that's not defined, right?
Right.
At least not at this level at this time. So you'd be looking at this axis. But this is not wrong. But remember, in order for this fraction to be 0, right? The numerator has to be 0, doesn't it?
Yeah.
So that's all I did there.
Okay.
Yeah, it's just something that we're not but that's how you would go through the logic of what I just gave you.
Okay. Yeah.
Does that help at all? Does that
No, it does. It actually does.
demystify anything that she didn't do, might have done?
Yeah, no, that means it makes me feel
More
a bit more
sense than
comfortable.
it did.
Yeah.
I mean, if you had some problems that you wanted to work on, we could do that. I'm gonna see if I have the because that's the other, like, it's easy for me to do the lesson, but if it's just a lesson and I'm not sure like where, because I don't know how sort of fundamental problems are going to be, you know what I mean?
Yeah.
So that's because what you're graphing has a lot of bearing on what you're graphing has a lot of bearing on how it's done, essentially, too. You know, how you graph it has a lot of bearing on that. So I'm actually looking for the one that we used last time. I'm gonna have to see if I can look it up from the tutoring session, because I'm not finding the one that we used. But I think it might be, oh no, that wasn't it, because I know it was a female last time that we looked at.
Yeah, it's just yeah, she's the thing is, I feel like, I mean, I know her heart's in like teaching, and I know she's a good teacher, right? Because of how much work she puts into it. It just gets so very confusing.
It's just that if she's not done it before either, then that's gonna be that would be a hard thing if they're making her teach it.
She was even talking about not teaching it next year.
I was looking up something earlier today, right? And somebody had written to one of the tutor platforms that I sometimes use for a little bit of help or whatever when I'm, looking for something. And I remember she wrote in and said, I'm a music teacher. And they asked me to sub. They asked her to sub this math class, right? And the kids are working on their trig, basically, right? And it's not hard, but they're working on, and she's like, I don't know anything about like the way this works. She was talking, and then they had some probability questions, and she had written in for some help, and she was like, can you just tell me what the theory is behind, because I don't know what they are. And
Really?
so somebody was like, and this is a person with, you know, she has degrees in music to teach music, not to teach.
Right.
To teach.
Yeah.
She's.
Yeah,
So,
it's.
you know.
Yeah, I know. I
takes a
know.
lot.
A lot of kids get frustrated, and I'm like, you gotta have grace. Like, it is like her first. You're even attempting to do this. Like, it's got to be hard.
It is, and it would be hard for any teacher. I mean, it would be easier, obviously, if you knew the material. But
Right.
it's the first time you teach a course, like, because I've been through a few of those with teachers that are doing it for the first time, and it is a little bit different.
Yeah.
Even if they know that, it just because you don't quite know how you want to teach it.
Mm-hmm.
And then you're like, oh, I could have done it so much better if I had, said this instead of that, or I should have.
And traditionally, she's actually an electrical engineer.
Oh, wow.
This is her second career.
No, so it's not that she doesn't know them, but it's a whole different setting, and
right. Yeah, I told you, she's very intelligent.
It's a whole different setting and a whole different.
Yeah.
This is the one that I was going to suggest you rewatch.
Okay.
Then we'll skip some of the parts, but this is her overview of polar rose. So this is where she goes over the forms and how long the petals are, and she talks about the periods, right? So this is a couple things that I wanted to point out. I'm gonna and you should be able to hear it as soon as I run it, but she gives you some idea. So here again, these are our rose curves, right? And recall that the period of the graph is the number of radians needed to draw the entire graph before it starts to repeat. So she goes through this.
A little different. These notes are going to be a little different because this is an exploration that we did in class. I didn't just do a lecture here. So I'm going to kind of explain what was done, and then I advise you to turn off the video for a minute and work on some things, try to figure some things out for yourself, and then turn it back on to get the answers. So the first thing we're going to do, I'll do this one with you, is we are going to graph the equation r equals 3 sine of 2 theta. And
now what kind of curve is that?
That's a rose.
It's a rose curve. And how many petals is it? It's gonna have 4 petals. Is it gonna have a petal on the horizontal axis?
No.
No, it's not.
See what some of the characteristics of this graph are. So let's go ahead and graph that.
So she's going to graph it for you just so you can see it.
3 sine of 2 theta.
Okay.
Right. Oh, that's it right there. 3 sine of 2 theta. So in polar form, we'll graph this. And we want to trace this. And the way to trace it, remember, menu.
You don't have to worry
trace,
about it.
This
is on her graphing calculator, but she just wants to point out something.
Okay.
And enter. It'll start tracing at 0 radians, which is what I want to do. So if we trace this graph, first of all, you can tell from the graph that this is a polar rose that has 4 petals, and we want to see how long the petals are. In other words, we want to know what the radius is.
I bet you can tell what the radius is. What is it?
It's going to be 3.
Yeah, it's going to be 3, but she wants them to figure that out. So she's going to trace it.
We're at the tip of the petal. Oh, and look at that. Looks like just by moving my cursor there, I pretty much hit it right there. It looks like the highest it goes is 3. I don't know if I can get it
Now that's
exactly the
how
3
long the
again.
pedal is. That's not the angle it is off the axis.
Anyway, I keep
Right.
Okay.
forth. Anyway, looks like 3. Now the question is, where is it 3? Because the next column asks, at what angle theta is the tip of the pedal? So it looks like it's 0.81186 radians.
So now she's asking you what is this angle, right? Well,
Mhm.
remember this, now this is a little bit harder because this is 2 theta, right?
Mhm.
And remember, this doesn't start, normally this has a max at 90, so this angle is 90 divided by whatever the coefficient of theta is. So this is 45 degrees. This pedal,
Okay.
see?
Radians, but
Mhm.
exactly how many radians is that? So what I would suggest you do is think about the angle that you notice here. The angle where these pedals are located. Notice that they're at 45-degree angles. So let's just assume that 45 degrees is the angle we're looking at, which would be pi over 4 in radians. And let's type pi over 4 in. So pi divided by 4.
Now she's really using a guessing check.
Notice at the
But
bottom of the
what I
screen
just gave you is the, because we know that the max of sine occurs at pi halves, right?
Mhm.
And your coefficient here is 2, so that's pi fourths. Now, how far apart are they going to be? Well, there's 4 pedals, right? So they're going to be 90 degrees apart. So this starts at 45, and every 90 degrees, you get another pedal maximum. So 45, 135, very similar to something we did earlier, right? Except
Right.
that I don't think it was a 3 sine. I think I just gave you sine. Okay.
Mhm.
0.7854. So at 0.7854 or pi over 4 radians, because it's what we just typed in, the radius is 3. And that's as far out as the pedals go. And then it gets, if I continued to trace using my arrow keys now, you notice that it goes in. The next thing, the last question is, what is the period of the graph? And I started tracing at 0. Notice that I'm up to 1.3 radians now. As I continue tracing these pedals, I've traced all but this last pedal now. When I get this pedal traced, let's see how many radians it is. Go back one, 6.28. So it looks like it takes 2 pi to go all the way around and trace all 4 pedals.
Okay.
So I'm going to fill in this
Okay.
chart. It has 3 pedals. I'm sorry, it has 4 pedals.
4
3 is
pedals.
the length of the pedals. It has 4 pedals. The length of the pedal is 3. Theta at the tip of the first pedal was pi over 4.
Which is
And the
45
period of the
degrees
graph was 2 pi.
and 2 pi. You don't have to worry too much
Now,
about the
this is
period,
a
but
point
it
where I would
might tell
say
you how
turn
many
off the
values.
video and
Okay.
continue doing the rest of this chart.
Now she's going to continue doing the rest of it, but let's see if we can do some of this. Okay.
Okay.
R is 4 sine 3 theta.
Okay. So it's gonna have 3 pedals because it's negative. Or not
No,
negative. What am I
it's going to
saying?
be odd, right?
It's odd because
It's going to have 3
sorry,
pedals,
my bad.
right?
3 pedals because it's odd. Then the length of the pedals are gonna be 4.
Right. Now here's the big question. Where is the tip of my first pedal going to start?
Okay, so do we do 90 divided by 3?
90 divided by whatever remember it's however many pedals. So yeah, 90 divided by 3 is going to start at 30 degrees.
30 degrees, which is pi over
Pi over 6.
6. Pi over
Yeah.
6.
Don't worry about the period. I'm not
Tracing and
you
trying to
you can do some of that, but
Yeah.
that will just, if you were doing it with the values, that would kind of tell you how many values you would have to put in, kind of.
Okay.
But don't worry too much.
Okay.
So let me scroll forward to some of this, right? So here's 3 and 4, right? Pi 6, right? Now, where is this coming from? 2 sine 4 theta.
What do you mean?
Well, here's your answers. right?
Right.
But tell me where she's getting them from.
Okay. She got the number of petals because 4 is an even number. You have to times it by 2 to get the number of petals.
Right, okay.
She got the length of the petals from the A, which is 2, and that's
From the
radius.
coefficient, good. Mhm.
And then she got the tip of the first petal by dividing 90 by 4.
90 divided by 4.
Oh, yeah.
So that's 10 degrees, and that's pi over 8.
Okay.
Because 180 divided by 8, right? So that's where this came from.
Okay.
Okay. And how about down here?
Okay, the number of petals, she got it from 5, which is an odd number.
Because it's
So
odd, very good.
That's 5. The length of the petals, because the A is 3,
Good.
that's the radius. And then the tip of the first petal she got by dividing 90 by 5.
Uh-huh.
Okay.
So now look down here and see, she's going to give you the general terms. Now notice the length of each petal, A,
A.
right?
And
Which
the
is
number of
our
petals is N,
coefficient.
right?
It could be N, it could be 2N, depends on if
it's even or odd.
Yeah, here she's using A and B, so we don't have N. She's using because she's calling this, see up here, it says A sine B theta.
Oh yeah, because B theta. Okay.
But you're correct. But remember,
Okay.
this depends on whether your coefficient of theta is even or odd. So
Got it.
far, you learned that, see?
Hey, I learned something.
And then here, now, this is the tricky part. So again, remember the maximum is pi halves. So here, this is where this can get a little bit. So here, let me back it up so she can explain this.
Pi over 2. 4 times pi over 8. Pi over 8 would give me 4 over 2. 5 times pi over 10. Petal. Now, the period of the graph. The period of the graph also goes.
We're not going to worry about the
B
period.
is
We're just
even.
gonna.
We'll take a look. Okay, let's take a look at cosine compared to sine. So I have.
Let me go back.
Or sorry, just B.
So here, this is, if you want to know what your tip of the first petal is, the value of theta that gives the maximum, okay?
Okay.
Think of the value of theta that gives the maximum sine, and that is pi half.
Okay.
Okay, that's where she got this pi halves, right?
Mm-hmm.
And you're dividing it by B, essentially.
Okay.
Which is what we've been doing. You take 90 and you divide it by the coefficient of.
Right. Okay. Sorry. Yeah.
Okay. So that's how that works.
Okay.
But that's, if you want to, I'm going to send you, in fact, let me put it in the chat right now. But this is, now this will be, because this explains not just, this explains some of the other stuff that you had some questions on.
Right. Okay.
And she gives you some graphs. So this, and she has a couple other videos on some polar curves as well. But this is kind of her review of some of that.
Okay.
I actually think she does a pretty good job of going over, like she doesn't do all the graphing, but it's a nice thing to kind of go back to so you can see what
she's not like that. What was that? That one guy who like he's in a classroom and he's like jumping around. He's like,
oh, yeah, no, there's a guy there that does that too, but she's
but I remember you not liking him.
This pattern is the stuff you need right now for this teacher. Like this is gonna help you with this teacher, I think. So this
pi. All right. Now, the next thing I want you to do, stop the tape. I want you to graph all of these equations up in the chart, only do them in cosine instead of sine.
Okay.
And then turn that back on and we'll take a look.
She's going to graph it. Now, here she gave them to you, but notice here's a nice thing about it. Notice that on this screen here, we
Yeah.
have 4 sine 3 theta, right?
Mm-hmm.
3 petals because it's odd. 4 units long, right? Sine
Right.
does not start on the polar axis. Sine here starts where? Where is my angle?
Isn't that pi over 3?
Pi over 2 divided by 3, which is 90 divided by 330 degrees, pi over 6.
Okay, pi over
But
6.
you're on the right track. You're dividing by 3. So
Right.
it's pi over 2 divided by whatever this,
Okay.
yeah, okay?
Okay.
Cosine starts on an axis,
Right.
3 petals, right?
Mm-hmm.
So I think we've sufficiently beaten
And they'll be
that.
different. They'll be what?
Up.
There'll be a 120 between
Right,
the
those would be 120. Uh-huh.
Okay.
How about these?
Okay. Take what? 3.
How did we get the 8 petals?
Oh, to get the A, you do 2. Or well, wait. A's the.
Be careful.
Wait. Sorry. Okay, wait. Yeah, A, like the length of the petal.
Okay, so how long is it?
It's 2.
2 units long.
2 units. Sorry,
Right.
2 units.
They're 2 units long.
Mm-hmm.
What's the 4 doing for me?
It gives you 8 petals.
Yeah, because it's even. So we have,
Right.
notice both of these have 8 petals, right?
Right, because it's 4 is even.
They both have 8 petals. Cosine always starts on an axis,
Right.
which is the one over here on your right. Cosine
Mhm.
starts.
And then sine starts.
Sine starts at pi halves
Right.
divided
Okay.
by whatever this is.
Right. Okay. So it'll be
So 90
pi over
divided
8.
by 4. Yeah, this is pi 8
Okay.
right here. And then
Okay.
how far apart are they? Well, there's 8 petals. So 360 divided by 8 was 45. These are 45 degrees apart, starting from pi over 8.
Pi over 8. Okay.
So you'd start there and then you'd keep adding 45. You see what I mean? That's how we do it.
Yeah. Okay.
That's how you figure that out. I'll let her explain it. Let me just back up just a tad so that you can actually, but that's, you see why I wanted to teach it?
Yeah.
This way?
Yeah. Oh yeah. This is a lot easier.
It's easier this way.
Yeah,
It just,
because
there's
it's
there's
lot easier.
details to keep track of. That's the only kind of,
Right.
but they're not hard. It's just not what you're used to.
Well,
Mhm.
where is cosine at its maximum? Since
So remember we were talking about the maximum, right? Where is
Right.
cosine at its maximum? So cosine, remember, has a max and then it falls.
It's at the polar axis.
So it starts at 0, right?
Sure.
cosine
Mhm.
starts high and ends high, like a cup that starts up, its maximum value is at 0. So it makes sense that the maximum value or the tip of a petal of the polar graph would be at 0. So what I'd like you to notice here is it rotates, so the tip of one petal of the first petal is at 0 radians.
That's whenever you have a cosine rose curve.
Now, the next group
Okay.
is saying go through and make sketches now. I'm going to erase this because I don't want you to see that yet. Make sketches of all of these graphs. This is now changing A and B to negative numbers and see what it looks
Now,
like.
what
And then
happens
we'll
if
talk
these are
about
negatives?
about what those
They
Okay.
come back.
wait of the
Of negative x
So
is equal
here, what
to
happened? It turns if this is 3 cosine theta, right?
Mm-hmm.
Negative 3 cosine 3 theta
Oh, it
turns your
reflects.
petals around, right? Because you're backing up along the axis. There's still 3 petals because of the 3 theta. They still start on a polar axis, but they're starting on the opposite side.
So they reflect.
Mm-hmm.
Okay.
Now here, notice she did something where she made the angle negative. But
Okay.
cosine is an even function, so that doesn't change the way this looks.
Okay.
Okay. So there's some kinds of symmetry things that take place with that, and she's
Okay.
going to go into that here a little bit. And then she has you
And
graphing
see if you can figure out how to do these without a graphing calculator. So you need to think, looking at
some of this. Now she has some other videos, but again, you can figure out how many petals you have and
Right.
where they're going to start from
Mm-hmm.
and how far apart they're going to be.
Okay.
So once you graph, then you can repeat it because they're symmetrical. Okay.
Okay.
She has several of these, but that's kind of where I would start with.
Okay.
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 And
Yeah.
I'll check in tomorrow again.
Okay.
We have some, I have 2 meetings that meet, one geometry and one stats. Sometimes people don't show up for the geometry one, but I have to keep it
Okay.
open. Kind of thing.
Okay.
It's one of those things where sometimes they pay me to be a prop, but sometimes I really do have to do some work.
Yeah.
So, but I'll check in, but that should give you a start on it.
Yeah. Oh yeah. My mind totally now got it. Like I feel like I actually like understand what's happening.
And the Limacons, remember, have to do with the ratio of A and B. And I think she has a video. The same teacher. I think she has a video on limacons and cardioids. I think
I'll look into it.
she puts the cardioids and the limacons, the snails together.
Okay.
But I remembered that video and I wanted you to see that one because I remembered that being really descriptive, but it was a lot for you in your trig
days.
Trying to get,
my trig days.
Well, that was a lot. We were
I will never forget. I'll never forget it.
I still have the notebook because there was other math in that journal besides, but like 2/3 of that journal was our trig homework together. So
oh my goodness. Every time we get a new lesson, right, and it has something to do with trig, my friends will ask me about like my trig days, and I'm like, guys, I had the best teacher ever. Her name was Shauna. And she was amazing. And they were like, oh, so I should take trig online. I was like, no, you should just hire Shauna.
it was not a happy place that we had going on there. It was but we, that was how was the actual class? Did you end up with something that you wanted, like in terms
the grade was like 93. Let's go.
Yeah, so
I was happy with the grade.
You had a lot of but I remember they were pressuring you too with like getting it done a week before and
oh my goodness. Yeah, you wouldn't believe it because I went to my counselor and I was like, because the day that I took the final test, I'd gone to registration and the counselor was like, she was just like, okay, so we're gonna put you in trig. I was like, yeah, but like I just finished trig today. And she was like, no, but I have to wait for you to get your grades. And I was like, no, I finished today. Like,
I
was like,
have my grades for you. Here they
I was
are.
like, I'll show you. I have a screenshot. She was like, no, I really do need. And I was like, okay. So I was intrigued for a few days, and I was doing the math homework because I was like, I might as well just keep up with it. And
Right.
it was a breeze. I was like, I actually learned something.
No, that was a lot of it was a lot, but we found a lot of material. And
Yeah. No, I actually learned something. I learned more with you than I would have if I had just struggled through that
that
class
was
by myself.
that was too hard. That was way too hard for that.
Oh, guess what I'm gonna do, Shauna? I'm gonna take the health version.
The what? The health version.
Yeah, so the school that I did the trig with, I have to do the health so that I can graduate.
Okay.
But it's not a year-long class slammed into 6 weeks. It's a semester-long class slammed into 6 weeks.
Oh,
So,
wow.
or summer, whatever summer. Yeah,
Okay.
6 weeks. So, but I have a lot of friends who have taken it and they're like, I did it. And this one, for some reason, you can work ahead. But in trig, you
okay.
weren't allowed to work ahead.
Mm-hmm.
Isn't that weird?
Yeah, that's kind of a, I'm looking to see, let me see if this has.
But trig, you
what
weren't
I
allowed to
need.
work ahead. But in health, you're allowed to work ahead, and it's not on Alex, so that's good.
Well, that was the other, but you had some decent material. I'll say that. Most of the material was
Yeah, but the grading
half
system was
was
weird.
halfway decent.
You
but-
get one wrong, you go all the way back.
So let me just this video here,
Okay.
see if we think this is useful. It may not be, so if it's not, we'll just pretend we never saw it and move on, and no hard feelings. Like we'll just move ourselves along and be, this is, I kind of start in the middle here. This is a snail curve. Okay.
Okay.
A plus B sine, A plus B cosine. Remember, if it's positive and there's a sign, it's going to be above. If it's this other one is A plus B cosine, now he's going to give you, I'm assuming, there's going to be some relationships. Yeah, he's showing you how you end up with a cardioid versus how you end up with a snail curve.
Mm-hmm.
Or you don't have a dimple in it. And then here you have we're turning it around. So again, if these are now, if this is if this is below, right? I mean above, then it's a sine curve. If it's to the right, then it's a cosine plus cosine. Right? Because remember we talked about, but these ratios hold for your dimpled curves and your cardioids, and that's why he's showing you this. So if it's plus B and it's plus cosine, he's gonna end up showing you what I was showing you with which way they open.
Okay.
Plus B cosine, and it's pi halves. Plus B sine, it's got to be above the curve, right?
Mm-hmm.
So let me go back here and let me
have cosine, or we can have sine. Okay. Wow, my lines are perfect.
So he's showing you
okay
the four combinations of A plus B sine and A plus B cosine.
Okay.
So if you have a positive B and we have a cosine, I'm shrink my stroke here.
Positive B and a cosine means that you're going to have something that opens Remember, x-axis opens to the right. So it's gonna look like this first fit. Now I could have an inner loop or not, depending on what B is, but it's gonna look something like this first.
Then your limaçon is going to be to the right of the theta equals pi over 2 line. So these
Theta equals
are
pi
all
over 2
positive
is what you would
limaçons,
think of as
okay?
the y-axis.
If we
Okay.
have sine in positive B, it's going to be above the polar axis.
So the polar axis is what you think of as,
And then the opposite if
x-axis.
it's negative. If it's negative, you're going to have it to the left of theta equals pi over 2. So these would be flipped. So we'd have, you know, my cardioid, instead of being like that, my cardioid would be like that, okay? And if it's a sine, then it's going to be below the polar axis. So if you want to know where the dimple is going to be, right, the flat side, the dimple, the cardioid, or whatever, that's always going to be kind of on the opposite side. So if I have a positive B, then that means my dimple is going to be over, you know, I mean, technically it's
so
not the
if
pole,
you
it's the
have a
cardioid, but
dimple, it'll
it's
be
gonna
on the
kind of, you know,
opposite
your lines are
side
gonna come out from
of the
left.
opening.
Or just, you know,
Okay.
the majority of the limaçon for these ones at least is going to be over.
That's what
Okay.
that means.
So that's how you can graph limaçons, and these
I will, you let me know how the lesson goes tomorrow.
Yeah,
And-
because I'm definitely gonna ask her about the graphing. Definitely. So
But now you'll have some language. If you,
yeah.
and if you want to refer to that, the video that I sent you, she does a really good job of putting language on the terms. So you
Okay.
can always look at a picture like this, and you can help her with the whole cosine and sine being the same. Because
Yeah. I think she's realized that now. I hope.
especially if she said that.
Yeah.
You know what I mean? Anybody can misspeak, but if she said that in a lecture, it's something that she needs to correct.
Really?
take
Yeah.
it to kids. You know what I mean?
Yeah.
Because anybody can misspeak, but that's gonna, like, if people take that and run with it, it's gonna mess a whole bunch of people up, and then
Yeah.
she's gonna be speaking English and you're gonna be speaking German, and people are not gonna understand what's going on. So
Yeah.
but she
Okay.
does a good job of putting language around it. And then if
Okay.
you need more help with the lemniscates and the limaçons and the cardioids, then we can go over some more of that.
Okay.
All
Cool.
right.
Thank you so much, Shauna.
You're
Thank you.
welcome, dear. Always good to
Woo.
see you.
It's good to see you too.
Hey,
It's
say
been
hi
forever.
to your mom.
I'll say
I'm
hi
sure
for you.
I'm sure your mom is stressing out over there.
When is she not?
Yeah, but there's levels, right? So
Yeah, they're very. Oh, I love her though. She's
all
great.
righty. No,
All right.
I love her too, but I'll talk to you
All right.
soon, okay?
All right. Bye, Shauna. Good night.
As soon as this renders, I'll let you know. It's gonna take